Okay, so let's get started. We're going to be taking a look in this training module at understanding our airflow and our torque modeling basics within our Gen 3 programming. Now, this is going to apply for both a Mustang and an F-150 application with the Gen 3 Coyote motor. We're going to first break down what the basic underlying equation that's going to tie together our fuel and airflow model. Then we're going to move into how the airflow model is used for a variety of different tables and programming in the engine control module. Then we're going to move into just understanding some fundamentals within our torque model, because the Gen 3 controllers are going to be pure torque based. There's a lot going on with this. Now, luckily, Ford uses a relatively simplistic torque model compared to something like GM, which can be quite complex. But there are some very different things within the Ford programming. If you're used to tuning GMs and you're coming into learning about Fords, there's definitely some quite different things the way Ford handles torque modeling and some of the programming that goes along with this. So as we go through the training tutorials and we start to break down these topics more in depth, you'll understand things a little bit better. But this is just giving you kind of a top level overview of what's going on in this training module. What I first want to do is open up a stock equivalent file so we can take a look at and cite some tables as we go through the training module. Let's do that first. We're going to go up here to File. Let's go to Open. And we're going to move into the desktop. Let's jump into our HPT Gen 3 Coyote course folder. Now, this folder is our course packet, which is available in our training course library. It's going to be the very first thing you find in the course library. It's going to show Gen 3 course training packet. Click to download. If you download that, it automatically download to your computer. You're going to have to unzip that file, which will then produce this folder. We're going to be using everything in this folder for pretty much the entire training course. So it's important that you do download that so you can follow through with our training modules. Let's go here to our HPT Gen 3 Coyote course folder, and we're going to move into our sample calibration file subfolder. In here, I have a compilation of a ton of different files for stock vehicles, for Roush, and Whipple-based kits. So a lot of good data in here I've pulled and I've saved along developing this course and along the last few years of doing all this. So we want to go in here and be able to reference things. I want to open up a stock equivalent file for the tutorial. Let's just open up 2020 Mustang GT manual stock. We'll use that as the reference point. Now, we will be jumping into the engine tab here, taking a look at and citing a few tables, understanding how our airflow, air mass fits into some of the programming. But for right now, let's close this out. I want to talk about the underlying most basic equation we have going on that's going to tie together our fuel model and our airflow model. It's actually really basic, but very powerful to understand. So that's going to be fuel mass is equal to air mass divided by target air fuel. This is how we translate a known amount of airflow coming into our engine into how much fueling we need to deliver so we're hitting a desired target lambda or target air fuel at any given time with our engine's operation. Let's break this down a little bit further, because you may not have heard the terms fuel mass or air mass. It's definitely kind of a little bit of an odd term for most people. If we break this down, we're going to find that mass is equal to volume times density. That's very important. It's a very important concept to understand. If we take a look at a cup of water and we have that same cup and we fill it with gold. So same cup, same volume. One is filled with water, one is filled with gold. Well, if we know the volume, that hasn't changed. But if we're talking about the density of water versus the density of gold, they're quite different. If we pick up that cup filled with water or we pick up the cup filled with gold, physically, we're going to notice a massive difference, which is going to be the mass. The mass is going to be completely different based on the difference of the density. So density is super important. And it's a very important concept moving forward looking at fuel mass or air mass, because we're counting for both volume and density and both of those variables. So if we're taking a look at and talking about air mass, that's going to be the volume times the density. The volume of the air is something that's easy to understand for most people. That would be the CFM of how much air we're ingesting into the engine. The density is where people get a little bit confused. So the density will change based on a barrel pressure, where elevation's at, and based on ambient temperature. So if we're at sea level, we're going to have a lot more oxygen molecules packed into the same volume of air compared to if we're at 10,000 feet of elevation. There's a lot less oxygen molecules packed into the same volume of air entering the engine. And that's important to understand, because the fueling for our engine, how much fuel we need to put in, is going to change based on the density change. Same thing with air temperature. If we're talking about the density of our air on a cold day versus a hot day, on a cold day, we'll have more oxygen molecules packed into the same volume versus on a hot day, we have a lot less oxygen molecules packed into that same volume of air. In that situation, we're going to find that how much fuel we need to deliver to the motor is going to be completely different. So, volume of air is important. The density of air is also important. When we're talking about air mass, that's going to be accounting for both the volume and the density. Now, when we're referencing air mass, and we're talking about a Mustang, we have a mass airflow sensor that's going to be measuring how much air mass comes into the engine at any given time. Now, that's going to definitely give us a good representation of both the volume of airflow, and it's also going to give us a good representation of some of the density. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.